ready for anything.
All right,
Except
we're gonna pray. I know not quite time, but you can finish snacking and then listen as we go. All right, let's pray. Dear Heavenly Father, we just thank you for the day, for the blessings you've given us. Thank you for the students here. I just pray you help them in their classes, Lord, as we finish up the year. There's not too many weeks left. Just pray you guide me in everything we do. In Jesus' name, amen. All right, so this chapter here, chapter 7, dealing with area between the curves, volumes, and length. Area between curves, volume, and length. They kind of all stem or relate to each other. So we want to talk about volume or area between the curves. Area between the curves. So this diagram on the left, I got two curves. I got the top curve, I got the bottom curve, so we're bounded. If I were just finding the area underneath this curve, find area underneath the curve, I would use what? How do I find area underneath the curve? Antiderivative or integral. Alright, the integral. Alright, and that's always the area between the curve and the x-axis. If I had this curve here, find the area underneath this curve. Alright, again, it would be between the curve and the x-axis. But that curve here, this would have a negative value. This curve here would have a positive value. So therefore, if I wanted to find the area in between the two curves, I would want to be able to take this one area here and add to this. Well, how do I change that subtraction to addition?
Absolute value.
What's that? Alright, we're going to subtract. Because when I subtract the negative, that is actually
Positive.
adding a positive, correct? 3 minus negative 2, that's the same thing as 3 plus 2. So if I take this curve, the integral of this curve, minus the integral of this curve, I should have the integral between the two curves. So let's look at an example.
This is chapter 7, right?
This is chapter 7, section 2. Alright? Section 1 we basically talked about before, so because of sake of time, I'm going to skip that. Say for instance, I want to find the area between y equals 2 minus x squared and the line y equals negative x. If I draw a picture here, there's y equals 2 minus x squared. And then here is y equals negative x. So I want to find the area between these two curves. Because of this example here, I'm going to always subtract the bottom curve from the top curve. The bottom curve, so it's going to be this curve here minus this curve. So when I'm looking at this, I can make the integral of 2 minus x squared minus
The integral of
negative x. Now I don't have to separate it in two integrals.
Oh.
Because when I subtract it, it's still going to be the same thing. So this is actually going to be the integral of 2 plus x minus x squared. What's the only thing that's missing? What did you say?
dx.
Well, dx, yes, it would be dx. But what else is missing? If I want to find the area between the two curves. Yeah, the endpoints. I need to know my limits, which are going to be
there
the
and
points
there.
where they intersect. How can I find the points when they intersect?
Plug in x. Plug in x for.
Use substitution or elimination between the two. That means 2 minus x squared equals negative x. That means x squared minus x minus 2 equals 0. When I factor, that'd be x minus 2, x plus 1. So therefore my x's are going to be, so this is going to be negative 1, and this would be 2 as far as my x. So therefore I'm going to go from negative 1 to 2. And I take my antiderivative. Negative 1 to 2, 2x plus x squared over 2 minus x cubed over 3. When I plug that in, that's going to be 2 times 2 plus 4 over 2 minus 8 over 3 minus, then you put the negative 1 in, negative 2 plus 1/2 plus 1/3. 4 plus 2 minus 8/3 plus 2 minus 1/2 minus 1/3. 4, 2, and 2 is 8. Negative 8/3, negative 1/3, negative 9/3, which is minus 3 minus 1/2. So it's going to be 5, so it's going to be 4.5, or 9/2. Which would be the area between the two curves. And because I'm talking about area, it would be unit squared. The area between two curves. Now, if you notice the difference in two diagrams here, this diagram and this diagram, we're still trying to find the area between the two curves. If you notice here that there's always a space directly in between the two curves. If you look at this one here, there is a space between the two curves here, but when we get to here, there's no space in between the two curves. So here we have to do one or two things. We have to split it up. We're going to find just the integral of square root of x from 0 to 2, and then we'll add to that the integral of square root of x minus x minus 2 from 2 and wherever they intersect here, which would be square root of x equals x minus 2, square that, that's x equals x squared minus 4x plus 4. So that would be x squared minus 3x plus 4. I'm sorry, 5x.
And you do it differently because.
Alright, because if you notice, there's a space, there's always a space between the two curves, but here there's no space between the two curves, so there's nothing to subtract. Otherwise, we would end up having that space as well, which is not, we do not want to include that.
So what do you mean by space in between the curves?
Well, the area is actually connecting the two curves. It's actually touching the two curves here. The area is not touching, this area here, the blue area, is not touching the top curve and the bottom curve. So therefore, we wouldn't be able just to subtract the two functions and actually get the actual area. So we would divide it up into two sections here. And again here, if I take this, I would find out that that would be x minus 4, x minus 1, which x equals 4 and 1. 4. That look right? That seem right. Wish I would know 1 didn't work because square root of 1 and 1 minus 1, 1 minus 2 doesn't work. That's what, that doesn't work. So we go from 2 to 4. So if we find the integral of that, integral from 0 to 2 of x to the 1/2, that is going to be from 0 to 2. What's the integral of 1/2, x to the 1/2?
2 over 3 times x to the 3 over 2.
Plus, here would be the integral of x to the 1/2 minus x plus 2. So therefore, I find the integral of 2x to the 3/2 minus
Wait, it's 2 over 3.
2 over 3 other, thank you.
Plus 1 x squared over 2
X squared over 2
plus 2x.
plus 2x from 2 to 4. Would everybody agree?
Yep.
Alright, so we put 2 in, that's going to be 2/3 times 2 to the 3/2, correct? Minus 0, which is 0, plus, then here, we would have 2/3, 4 to the 3/2, minus 4 squared over 2, plus 2 times 4, minus 2/3, 2 to the 3/2, minus 4 over 2, plus 4. Two-thirds, 2 to the 3/2, plus square root of 4 is 2, 2 to the 3rd is 8, 8 times 2 is 16, over 3. 4 squared is 2, divided by 2 is 2, so that's minus 2, plus 8, minus 2/3, 2 to the 3/2, minus 2, plus 2, minus 4.
Wait, why is it minus 2 there?
Yeah, wouldn't it be
Wouldn't it be minus
minus
8?
8,
Because
16
4 squared
over
is 16 over 2. Right.
in the middle?
Yeah,
Here?
it's-
Yeah.
Yeah.
16, oh, that's right, I'm sorry,
So it'll be 0.
8, right? Alright, so this 2/3, 2 to the 3/2 cancels out with this one. This 8 cancels out with this one. This is -2 plus 16/3, which that's 6/3, 16/3 minus 6/3, which is
10 over
10 over 3.
10/3. Would be the area between those two curves. Now, there is another way that we can do this that we want to look at. Because if we integrate according to the green, now there is a space between the two curves. So what we would need to do, we would need to integrate according to y and not x. So we would solve for x. So x here equals y squared, x here equals y plus 2. So now we're going horizontally. What's my top curve? Here's my top curve here, the y plus 2. So it's going to be the integral of y plus 2 minus y squared. So instead of going this way, vertically, we are going this way, horizontally. If we integrate horizontally, we have to change it into respects to y, not x.
If we go horizontally, wouldn't the top curve be y equals, or x equals y squared?
Because remember, right is positive, left is negative. So it further to the right would be top, further to the left would be bottom. Yeah. So it's just like if we flip this upside down. So this would be my curve. I am going from, now I'm going to go from y, which is 0, to here. Well, if my x here is 4, my y is going to be 2. Right? If we put 4 in for x, y equals 2. So I'm going from 0 to 2. So that's integrate 0 to 2, y squared over 2 plus 2y minus y cubed over 3. Plug it in, that's going to be 2 squared over 2 plus 2 times 2 minus 2 cubed over 3, and this would be minus 0, correct? 2 squared over 2, 2, plus 4 minus 8/3. 2 plus 4 is 6 minus 8/3. 6 is the same thing as what over 3? 18 over 3 minus 8/3, which equals 10 over thirds units squared.
So they should match.
They should match, yes. Because it's the same area, it's just, we just did it, orientated it a different way.
So is that just to check it, I guess?
No. Which would be easier? Is it easier to try to split it up, or easier to do it in respects to y?
Okay,
Alright?
interesting.
In respects to y would be easier. Now,
Will we have to memorize both ways?
memorize both ways? Not necessarily memorize both ways, you just have to recognize that, hey, it's easier to do it according to y than according to x. Take for instance, we had no, that's not what I want. Let's say I had this curve, and I'm looking for the area between these two curves. Alright, so again here, I have vertically, I have area in between the two curves, but here there's only area between one curve. So I can't even do it in respects to x here, so I have to do it in respects to y here. So I have to be able to look at the diagram and see, well, do I need to do it according to x or do I need to do it according to y? And then make your decision on how to do that. And so in this case here, I would do it according to y. So let's look on page 395. If I look at page 395, number 1, I would do it in respects to page 395, x. Number 2, I would do it in respects to x. Number 3, I would do in respects to,
Why?
Well, it doesn't really matter, right? For,
you can do it either way, x or y. But number 4, I would do it in respects to y. Number 5, in respects to x. And number 6, I would do it in respects to x. We flip it over on page 396. Number 9, I would do it in respects to
Y. Yeah, Y.
I would do it in respects to y because there's no top. Because when we look at this, we have this equation and then this equation,
Um,
if I just use these two graphs here, there's no top, I keep on going forever. So I need a ending point, so that's where this line comes from. Now I have a top. Or in this case, if I do it in respects to y, this way, I have a side, I have a limit from 0 to this side here, which would be 1. So I would do it in respects to y in this case. Alright, number 10, do it in respects to
X.
Why?
y.
Why?
Two endpoints.
So you can.
Well, again, when you look at this, you have this, and then you have this. Is there an area between the two curves here?
No.
Now, you could do it in x if you split it up. But you could do it in y without splitting it up, because there's always a space in between the two curves.
so are you basically looking at the limits?
Well, I'm looking at the two curves and also looking at the limits. Because here, again, if we're finding the area between two curves, the area must be in between two curves. If I look at this section here, is this shaded portion in between these two curves? Well, it is if I go horizontal, but it's not if I go vertical. If I go vertical, then I would need to divide up the two integrals into two separate integrals to do it that way. And you can do it either way.
But
Yep.
even if you divide it up, technically it's still not between two curves, right?
Well, if I divide it up, I'm just finding the area below this curve plus the area below this curve,
Okay.
if I divide it up. Number 13, in respects to,
I think it's X.
So this one would be x.
an x,
It wouldn't really matter, right? For
that one there, doesn't matter, you can do it either way. And number 14,
Yeah, there's no Y.
Yeah, y.
What?
mm,
X.
X.
Oh.
I would do it in between the x. Because there's always, vertically, there's always an area between the two curves.
Okay.
But what about the areas on the ends?
Where you have your endpoints, that red line, that means where I'm gonna go from -2
Oh.
to -5, or -2 to 3. And that's as far as I would go. Okay? So you just have to make a decision, alright, do I need to do it according to y, or do I need to do it according to x? So let's look at another example. Let's look at number 2. So you get the first curve, which is y equals 1/2 secant secant squared t. And you get the second curve, which is -4 sine squared t. Alright, so if we're going to do it according to x, we can subtract the two curves. The top curve is 1/2 secant squared t, correct? We're vertical. Minus the bottom curve, for sine squared t.
Wait, what does secant squared look like again?
Secant squared. What's that? Alright, my limits are
5 to the third, pi over 3 and negative.
5 over 3, negative pi over 3. Now I can take the integral of secant squared t fairly easy, because I know that is going to be what?
That's
That's
tangent.
Tangent t. Secant squared t, though, is a different story. Remember back when we started doing integrals with secant squared t, we couldn't do it. Couldn't do it by u substitution because there's nothing to take out. If I said u was sine, du was cosine, and there's no cosine to take out. So we had to use one of our trig identities,
Wait, are we talking about secant or sine?
sine.
Oh, you said secant multiple times, so,
But we know what secant squared t is, right?
yeah.
Okay, so it's the sine squared t that we're having difficulties with. So yeah, I apologize if I said it wrong. We know that cosine 2t equals 1 minus 2 sine squared t. Correct? We can solve for sine squared t to get 1/2 minus cosine 2t over 2.
Couldn't we leave the two in there and just factor out the two
The
from
two.
the integral?
Got out the 2 from the 4.
Do what?
Factor out the 2,
Factor out the 1/2?
no,
No, take out a two from the integral, so it'll be 1/4 secant squared t plus 2 sine squared t, and then just use the identity from,
You could. So all I'm gonna do is just plug it back in. I'm gonna put integral from negative pi over 3 to pi over 3 of 1/2 secant squared t plus 4 times
oh,
1/2 minus cosine 2t over 2 dt. Which in that case, I can factor out the 1/2. And there's different ways you can approach this.
Okay.
So therefore I got 1/2 integral from negative pi over 3 to pi over 3. Integral of secant squared. Integral of 4.
4x. Or 4,
Integral of cosine 2t. Or 4 cosine 2t.
just 2 sine 2,
yeah. Minus 2 sine
1 a plus.
of 2t.
Be plus, correct?
Wait, how's it plus?
Because it's minus.
Because the integral of cosine would be negative sign. Integral of cosine, antiderivative of cosine,
Is sine?
negative sign. Because the derivative of sine is,
Cosine.
alright, derivative of cosine is,
Negative sine.
yeah. Correct? No? Alright, I was wrong. You're correct. Alright. Pi over 3. Tan to pi over 3.
9 square root of 3.
Wait, what? Yeah.
Sine of 2 pi over 3.
And that's square root 2 over
Square root of 3 over 2.
of
tangent of negative pi over three,
Wouldn't that just be plus? Oh, no, cause, well, yeah.
Be minus square root.
right, this is negative square root of three, so minus will make it plus square root of three. Sine of negative two pi over three,
That's plus square root of 3.
plus square root of three. This square root of three cancels out, this square root of three cancels out. This 4 pi over 3 and this 4 pi over 3 cancels out. So that's 2 square root of 3 times 1/2, which is
Square root of 3.
square root of 3. Unit squared. And our answer is wrong. Yay.
That's,
Our integral is not wrong, I do not believe. Tangent of pi over 3, let's just do this again. Take the 1/2 out. So that leaves 4 t minus 4 cosine 2t. Alright. Integral is tangent, integral is 4t, integral is minus cosine 2 sine 2t. So put pi over 3 in, tangent pi over 3, 4 pi over 3,
Would it be minus 4 negative pi over 3?
Oh, yeah, you're right.
The second one?
So tangent pi over 3 plus 4 times pi over 3,
So
it
it
would
would
be minus.
which one?
The
The
4.
second 4
Right here?
pi over 3, that'd be minus because the whole thing is.
Wait a minute. Oh, no.
Because the whole thing is
No,
minus.
It changes, but
It is
Alright, let's do it this way, let's do it,
Hold on.
No, oh no, it is probably.
Yeah.
let's do it that way. Minus tangent, negative pi over 3,
So it'd be
negative
negative
negative pi over
tangent.
3.
So it'd be
Okay, so,
Alright, so this is pi over 3, this is 4 pi over 3, this is negative pi over 3. So this would be negative square root of 3, correct?
yeah.
Minus would be a plus. This would be negative 4 pi over 3, so this would be a plus 4 pi over 3.
That would be.
This would be a plus, so this would be a minus. There we go. So the pi over 3, the pi over 3, pi over 3, the pi over 3, so therefore it'd be 8. 8 pi over 3 times 1/2, there's the 4 pi over 3. So I messed up there. So again, some of these can get kind of lengthy, so just be careful. Don't make the same mistake I did, try to do too much in my head. We don't make a careless mistake. Look at another one. Let's look at number let's look at number 24. X minus y squared equals 0. And x plus 2y squared equals 3. So if we look at this, x equals y squared, so that's going to look like this. This is x equals 3 minus 2y squared. So that's actually going to look like something like this.
So in this situation, it wouldn't matter if you X or Y.
This situation, it would matter. Because At this point here, you only have area between one curve. If you go vertically, and here the same way. So here, if you go horizontally, you have area between both, actually all the way between both curves.
I still can't picture turn, you like.
Alright, so if I did it vertically, between the X, I would want the area between the two curves touching the two curves the whole way.
Okay.
So at this point here, this is only touching the one curve, the area between those two lines. Because this is one curve right here,
Yeah, okay.
okay? I really want it between the two curves. So therefore, if I went horizontally, now it's touching both curves.
Okay.
So it'd be better to do it in respects to Y. In other words, I want to solve for X, which I have them solve for X now. Alright, which one is the top? The furthest one furthest to the right. So this one is the top. So I'm looking for the integral from 3 minus 2y squared minus y squared. And then we can simplify that to be the integral from 3 minus 3y squared. Now all I need to do is find out where those points are. So if I set them equal to each other, y squared equals 3 minus 2y squared. That's going to be 3y squared equals 3, y equals plus or minus 1. So therefore I know I'm going from -1 to 1. Now I'll take the integral. Integral of 3 is,
3x.
in this case, 3y. Integral here is going to be y cubed. That's going to be 3 minus 1 minus -3 plus 1. Correct? 3 minus 1 minus, and I put -1 in, -3, -1 in, plus 1. That's going to be 3 minus 1 plus 3 minus 1. That's going to be 4 units squared. I don't know if we have time for one more or not. So I got number 36. It says the region on or above the x-axis bounded by the curves 4 minus x squared and y equals 3x. So look at the picture. Oops, -2 plus 2. And 3x should look like this. So I'm looking for the region on or above the x-axis bounded by the curves. So I just want that region there.
And we would do, so in this case, now it doesn't matter if we do y or x, or y or x, because both ways, there's a point where the area is not touching them.
Yeah, so in this case, you're gonna have to split it up.
Okay.
Yeah. So we could take the integral of 4 minus x squared from -2 to 0 plus the integral from 4 minus x squared minus 3x from 0 to whatever this point here is. which we would have to find. And we can find that by setting equal to each other. Oops. So this would be 1.
Wouldn't it be
Wouldn't it
4?
be x plus 4? Yeah, that's it.
What's that?
Wouldn't it be
X plus 4.
X plus 4.
it's f x plus
And
3
the 0 would be negative 4.
Where we at?
with the 0?
Here?
No, the
The,
next step,
when
Here?
you factor,
the next step, that one.
It'll be x plus
Yeah. Correct. Yeah, cause this point over here is negative 4, which we don't need that part, point. Are the integral? Correct? Alright, then you put zeros in, the ones in, you'll be able to figure out your integral. Alright, tonight's homework is Math Excel 7.2. And then tomorrow we'll work on some more of these. Alright?